Hello class, this is Ernesto and Caroline and we're doing properties of logarithmic functions. The characteristics of typical logarithmic growth and decay are summarized below. And this is what a regular logarithmic growth and decay look like. The domain for a logarithmic growth function is from 0 to infinity. The range is negative infinity to infinity. The x-intercept is 1. The asymptote is the y-axis. And the end behavior is as x goes to infinity, y also goes to infinity. And as x goes to negative infinity, y will also go to negative infinity. And it is continuous from 0 to infinity. But this is just for a standard log function. If you have a minus thrown in or some parentheses thrown in, it's gonna shift, and we'll talk about that later. In logarithmic decay, for a standard one, the base of b has to be between 0 and 1. The domain is from 0 to infinity, while the range is negative infinity to infinity. There's no y-intercept because it'll never touch the y-axis, and the x-intercept is 1. There's no extrema, and the asymptote is the y-axis. And the end behavior is as x goes to infinity, y will go to negative infinity. And as x goes to negative infinity, y will go to positive infinity. And it is continuous from 0 to infinity. But as we'll talk later on, this graph can go to the left or to the right or up or down as you add parentheses and minus or plus signs to it.
Now we'll be talking about graph transformations in log functions. Look at this function right here, log equals x plus 4. As you can see, if you this changes the graph 4 units to the left as shown right here. And in this one, if the log is negative, it is reflected across the x-axis, and the y-intercept is moved down 5 spaces. And in C, the log, as you can see, gets bigger by a factor of 3, and it gets shifted 2 units to the left because of x plus 2.
I'll just add something. Here, I'll add something. Just as a general rule, if it's in the parentheses with the x after the log, it will be the opposite sign, and then that will mean you move it left to right. If it is not in the parentheses, then it means it's going to be moving up to down with that sign.
Let's look at some problems. In here, they ask you to use the parent graph of f of x to find the equation of each function. So in 60, you can see that g of x is just log of x, just shifted 2 spaces to the left. So what you have to do is get log of x plus 2, and that's what g of x equals. Because when you have parentheses, you're moving the equation to the left or to the right. And in 61, you can see that h of x is just log of x shifted 4 spaces down. So what you have to do is log of x minus 4, no parentheses. If you don't use a parentheses, you're moving the equation up or down.
To find any answer for a log equation, like the previous lesson had mentioned, you would fill in the given value, and then, taking that given value, you would put it in for whatever variable it is, and then solve using the log button on the calculator found in the bottom left-hand corner. Same for the natural log button. And then this would give you, for example, this problem. The constant is 1.0 times 10 to the negative 12th watts, which would be W0. And then the given is 3.16 times 10 to the negative 8 watts per square meter, which would go in for W. So therefore you plug those in, and when you divide and then take the log of that number and multiply it by 10, you would get 45. And that would be your answer. And you would do the same for all these down here. And you could also then put this original equation into your calculator to get this and make a graph, which then would give you these answers. To find the inverse of a log function, you would use the form x equals y, and that would be equal to x. So applying that to this, you would change it into switch the x and the y's, to get x equals 2y.
Okay.
Then you would take
The making of.
Then you would change that using that form to get 2y, the x value, into 10x, because the original base of log, when it's not mentioned, is 10. So the b value would be 10.
All right.
Then divide both sides by 2, and you get y equals 10 to the x over 2. And that would be the inverse function. To get the domain of this, you could either graph or make a table.
Okay.
To find the inverse of natural logs, you would take it and start by switching the x and the y with all inverses. Then you would take it and you would times both of them by the natural log, so ln of x equals ln of e to the 3y, and because ln of e equals 1, then that just becomes 1. And this, because I use an exponent, is equal to 3y equals ln is equal to 3y times ln e.
Okay.
Exponents can be moved to the front. So then you end up with the equation ln x equals 3y, and technically that's times 1, but you don't have to include the times 1. And then divide both sides by 3, and you get ln x over 3 equals y. And once again, you would find the domain by either graphing or making a table.
Okay.